Data management, right? Well, what it has in common with safety and planning is if you don't do it, life can get very painful very quickly. So for the next hour-ish, we're going to talk a little bit about some of the principles and motivations for thinking about drone data management. When you're flying for fun, when you're flying for, taking video, this is not really a concern. But as you've probably heard this workshop so far, to go from recreational flying around an obstacle course or doing some little videos around your neighborhood to photogrammetry, it's a big leap in the workflow, right? Many additional steps and requirements come into play, and data management is one of them. All right, so Shane and I are going to talk about this. This slide deck will be shared with all of you. It has 7 sections. We're going to aim to cover 6 of them today. It's not really meant to be covered in all, but you will have the slide deck. And if you're interested in how our group does our data management, which is the last piece of the slide deck, we're happy to talk to you about that one-on-one. And I think we'll try to hit some of that this afternoon, so you can watch the recording of this afternoon session, which will basically be the same content. But I'm going to start out by talking about why should you even have to think about this? All right. So the amount of data that you get when you're flying drones for mapping, not surprisingly, it's going to vary with the size of your area, your study area. But it can quickly expand. But it's not just the size of your area. It's like how many times you fly it. What kind of camera are you using? A 40 megapixel RGB camera is going to be a lot more data file sizes to deal with than a 12 megapixel camera, right? So picking, what is your requirements and what is available for your drone platform is part of it. If you're working with multispectral camera, right, that's 4 images for every point on the ground, right? The 3 up to, maybe more, like 5 multispectral images. If you're flying low, if you're flying high, you may need more or less. So anyway, but the point of it is you can quickly come up with a lot of data, even for like a modest area, maybe 20 acres. You can wind up with, hundreds and hundreds of gigabytes of just the raw data. All right. This is a schematic that kind of represents the relative growth of the data that you have to deal with as you're going from still photos from your drone to your final product, right? So, you definitely get some data when you acquire the images. So that's the raw images. And, you'll need a little bit of like GIS files perhaps to do the planning. But the photogrammetry step is where the size of the data that you have to work with, it grows by like a factor of 10, right? So the outputs that you get in the intermediate products that the stitching software produces, they can be quite large. And you may not need to keep all of those for time immemorial, but you do need to keep them for a while. And then depending what your final goal is, you may have additional products that you're creating. So you have an orthomosaic, but maybe you need to feed that through a classifier or do some other modeling with it. So the point is as you go through the workflow, you get more and more data to deal with. And it's only at the very end of that pipeline is where you get your results. And it's not just the volume of data, it's the diversity and the breadth of different types of data, right? I won't go through all of this, but you can kind of get the idea that images are definitely the big chunk of it, but there's a lot of other stuff to keep track of. If you have field samples, if you have ground control points, you got to keep all of that. If you're keeping your logs, sometimes you take other photos of your project, you're not going to stitch them, but maybe for your calibration panels, maybe just, for your presentation. So there's lots of stuff. Often there's going to be some GIS files that you might want to deal with. Metadata, that's one that we'll be touching on a lot today. So a lot of different types of data. So one option that many people do is they use one of these online platforms. You fly your mission, maybe with drone deploy, PIC3D captures, Esri site scan, it lands, you go from your tablet up to the cloud, they do all the processing for you. And then like a couple hours later, you get a email, your job is done, you go to the dashboard, everything's ready. They handle all of the data management for you in the background, right? So that's a big perk of a lot of these platforms. And they may do it to greater or lesser extents, but that's one option. And a lot of companies and researchers who don't have the bandwidth or the time or the interest in manually doing all their data management, this is one of the reasons they might want to do that. If you do want to come up with your own data management pipeline or workflow or system, these are some things to think about, like storage. Just basically, where is it going to go? Is it going to be on your hard drive, an external hard drive, in the cloud, some combination of that? How are you going to be able to find what you're looking for? Imagine you fly and like 6 weeks later, you come back, now you have to start working with the data. You got to find the files that you need. You just can't like throw everything to My Documents as we used to do, right? So it has to be organized some way. How are you going to document the stuff that's important to help you find, right? The project or the flight name, the project area, the sub-project, what camera you were using, what was your precision, were there clouds in the sky when you flew, all that stuff, broadly termed metadata. There's different formats. You've got GIS formats, you've got raster file formats. The GPS software often have their own proprietary formats. You may have to deal with that. Big data might be, transferring it from one location to another may not be trivial. If you want to back up 800 gigabytes of data to Dropbox or Google Cloud or something, that's not going to be the same or as easy as simply, dragging it from your computer to an external hard drive. So you have to think about what tools you're going to use to transfer data. Privacy and security can be a concern, depending what your project is, depending who your client is, or what you're going to do with the data. That's not trivial, not trivial at all. The online cloud processing platforms, they do a good job of that. So that's another reason people like to use Esri or Drone Deploy, because you can share it with different levels of permissions. Sharing, that's another thing, right? And then backing up and archiving it. So lots of things to think about. Maybe not all on day one, but broadly, you should have some of these things in mind when you're planning what you're going to do for your. So let me pause there, just briefly, see if there are any questions. Okay. All right. Okay, so let's talk about some general best practices, right? We're keeping this kind of general. Before you even get into the vehicle and go out to the field, what are some general best practices? So you're going to need, almost all drones, you're probably going to be putting in memory cards, right? Many cameras do have some internal memory, but they're rarely large enough. Most sensors, I don't know any sensor that's not designed to take a memory card, right? So you need, you need to get some memory cards. The micro SD cards are pretty common, or just a regular size SD card for some of the multispectral cameras. A gold standard would be, I would argue, a gold standard would be to have one card per flight. If you're thinking, I'm going to get 10 flights in today, the gold standard would be have 10. That's not always practical, but if you do have one card per flight, the drone lands, you pull the card, you can copy it. You should probably still copy it to your laptop, but hold on. Yeah, I'm gonna get to that.
And then you could stick in each of those flights into a nice little memory card holder like this and label it, so you don't lose which flight goes with what flight operation and which SD card. So the good way of keeping your stuff organized, this is just a simple memory card holder, Amazon, $8.
Yeah, so if you do have one card per flight, then you don't have to reformat the cards in the field. You don't have to erase them. So you have, that's one backup copy of every flight is going to be the card. That's not always practical, but that's useful if you can swing it. How are you going to store and manage your cards, right? So Brandon just mentioned, I'll hold this up for a little, there's different types of card holders. There's these little ones you can fit this, multiple 8 or 10 or more cards in it. There's little spaces where you can label this. probably a good investment. I also carry, you know, some Altoid boxes and lots of these little plastic covers. Think about how you're going to manage your cards in the field. Yeah, that's a good point. I'll get to that. All right, so different storage cases. Shane just highlighted if you are going to be transferring cards or images to your laptop to preview them, which we'll talk about next, make sure you have a card reader, right, on whatever device you're going to use to preview the images that you just flew. All right. We often get questions like, should I get 256 gigabyte SD card? Card storage in general is not a huge problem. I mostly use like 32 or 64 gigabyte cards. Depends on the camera that you're flying, but you don't need the super massive cards. And in some ways, there's some risk to having a really like 128 gigabyte card. As we heard yesterday, some of the multispectral cameras only support FAT32 formatting, so you have to get some utility to format a large size micro SD card in FAT32. And there's just a lot of data that could fly away, right? Or that could like fall into a puddle or something, right? So I would rather have like 8 32 gigabyte cards than like 3, 256 cards or something like that. More cards is better than big ones. Okay, so in the field, we just mentioned if you're going to be juggling cards, have a system. It might involve labels. It might involve, little cases, but it's easy to like mix up what cards. It's like, oh, I just put that one right there. What flight was that? Was that number 2 or number 3? So have a system. If you have a helper who can help you with this, that's useful. It's not hard to get your cards mixed up. We've heard a couple of times, do you want to keep a log of your flights, right? Sometimes paper and pencil, a little notebook. Flight 2 started at 10:20 and went to 11:15. That way it might help you back in the office know that, oh yeah, this set of images was from that flight and we remember where that was. There's also apps can do that for you, maintain your flight logs. I think all of the mission planning apps will allow you to save your flight plan. So click that save button. So again, you have a record of it. One of my pro tips would be, and this is something not everybody does, preview the images after your flights, at least at the beginning of the day or the beginning of the week. If you're going to have problems, you want to know about them while you're still in the field, not when you get back to the office, that night and say, oh, half of these images are blurry, or we use automatic white balance and half of them are purple and half of them are yellow, right? Those kinds of things. You want to see them in the field. One option is all of the flight management apps that you have on your phone or your tablet. They generally do have a way that you can, after the mission is over, they can transfer the images to the app and you can preview them. You can at least see if they're blurry or not. This involves copying the images from the camera on the drone to your tablet. That's usually done wirelessly. We generally don't use that. I'll explain that in a minute here. But that's an option. Some of these apps, like Pix4D Capture or Drone Deploy, they will also allow you to upload your images from your device to the cloud and actually start processing them, at least enough that you can see if you had any dropouts, right? So dropouts is another thing you can worry about. And they give you an option to preview those for qualities. So myself and the people in my group, we generally do not use the flight apps to preview images after flight for a couple of reasons. Number one, we don't want to waste battery time to transfer the images from the drone to the tablet through Bluetooth or however it does it. It's also kind of slow, right? It's a lot slower than transferring that. It's definitely a lot slower than pulling the card and just putting it into a card reader. So we generally don't do that. but it's not a bad idea, right? And it's, again, for the beginning of your mission, this might be something you could think about. And those of you who have experience with this stuff, instructors and other folks out here, please chime in if you have other experiences, because a lot of this is kind of like the craft of it. Okay, another option, and this is generally what we do in the field, is we copy the images to a laptop through, we pull the memory card, stick a fresh one in, load up the images into the laptop and look at them. All right, ideally, when you copy them to your laptop, put each flight in its own folder, hopefully with a name that will help you remember that this was like Northwest Corner flight or something like that. Just previewing the images in your Windows photo app. You can see, is this clear? Is it blurry? That by itself will give you a bit of information. If you can start stitching the images, a lot of these stitching programs have a quick stitch function. At least, again, you can see, oh, we lost a whole flight line here. We're going to have to repeat that, right? So that's a reason that you can start your images, start processing. But I guess my number one pro tip, and again, this is because it's something we often fail to do because we're busy, we're ambitious. We only have 2 days out there. We need to have a large area cover. But for all of this stuff, just budgeting some time, especially that first day, plan to have some flights that you're not actually going to process. They're kind of like test flights to make sure everything's working, you're getting good data, and then you start nailing the flights down, right? So, but this would be my number one suggestion, particularly as you're getting started. As you'll see, there's lots of glitches to deal with. Your camera's not talking to the controller, or you can't get your airspace clearance, or something. There's always something. You didn't do a firmware update. You missed a battery firmware and you're getting an error message, right? Always budget time at the start of a project. Best practices when you get back to the office. You definitely want to have a backup copy of your data. You can redo stitching, but you can't get the images that you flew yesterday, right? The system has changed. So protect your raw data. Make a backup copy on another storage device on the cloud. At least have another copy. We often will not format our cards until we're positive that we have an extra copy, because the cards are one of the copies. Another good practice is organize your data into some kind of directory structure. Depending how big your area, maybe the date, create folders for the week, for the site, for the camera, to help you keep your stuff organized.
One addition to this, if you work on a team, one addition is if you work on a team, try to use the same data structure so other people can come and know what they're looking for and looking at.
Very true. Yes, when you're working with teams, everything there's another level of coordination that's needed. Avoid very long paths. We'll get into, but using consistent names, as Shane was making reference to, right, will help you. All right. Okay, so those are some general best practices before the field, in the field, and when you get back to the office. Let me pause for questions or other best practices that people have found useful. Yes. Yeah, so the question was, how do you deal with the trade-off of the time, the amount of time it does to do the field, and maybe the window that you really have to nail, because of light, or because that's when the satellite's about to pass over, right? There are some, I have no simple answer, just to be prepared for that. A lot of times we'll show up at a site maybe around lunchtime and then spend the afternoon testing the equipment. And then the next day is when we're planning to actually get the real data. So you may have to, get a day in advance, or just practice maybe, in the morning and then drive to the field, and at least you'll see if your equipment's going. Brandon. All right.
test it out with the new one, get on the next launch, and then from there, that new SD card, the old SD card, put into some computer with different codes while the drone is.
So Brandon is saying teamwork is another strategy, and having a well-oiled team where people know what they do. Someone's handing the cards, someone's doing the checking, someone's planning the next mission, and your pilot's ready to change the batteries. That's another way that you can work quickly in the field. Great suggestion. Yes.
You guys have like a list of products, especially for card readers and all that you guys like or prefer to use. They're not moving around big files that take a long time.
Yeah, good point. I don't think we have a list like in our group, but we do have a Google Doc where people could share like the stuff. Always look for USB 3, so the faster speed USB devices. USB is not one thing, there's different speeds to it. We have a colleague who would Velcro a small external hard drive onto the laptop case. And the cable is another piece, right? That can slow you down. You can have a super high SSD card or SSD drive, but you need the special cable to get the maximum transfer speed out of it. But maybe we could do that. In our Google Doc, we could ask for people to share what they have found helpful for devices.
For recognition, SanDisk is one that I use for cards and for readers. Make sure you check out the highest speed SD cards. About 238, I think it is for. They keep on adding more letters to the end of the speed numbers.
Yeah, so Brandon is endorsing SanDisk, as well as when you buy your SD cards, look for high-speed ones that are designed for like cameras. Yeah, I would totally endorse that. Don't get the the 595 SD card. Look for a reputable. That's not only for transferring speed; it's also for reliability. That the camera is saving images to this card on the camera as the drone is flying, like every 3 seconds. So you need a fast card that it can keep up with. Other suggestions or questions? Yes. Good question. In general, if you have a paid account with Drone Deploy, Pix4D, Esri, I don't think quick stitching is ever a premium feature. There's Pix4D field maps, that's all it does, but if you have another one of the ones. So I would say probably that's not going to be a hurdle for you, the price band. Others, please correct me if they know. Yes. The question was when it comes to these platforms to deal with all your data needs, doing the flights, stitching the data, are they generally comprehensive? They do the stitching. The general answer is yes. These companies, they're trying to be the one-stop shop. And yeah, so if you have a subscription or plan, they generally will cover everything. And when you're shopping around, check, can I share my data in the cloud? We'll talk about Esri's options in just a bit.
One addition to your question about price and how they handle it, it's usually based on the number of images that you upload to their service. You're allowed a certain number of images per level of the account you purchase with them. And often these systems that don't necessarily handle multispectral, they definitely handle RGB. So you really have to pay attention to that when you sign up for the services.
Yes. The question is, what kind of algorithms do they use to stitch the images? We have a session tomorrow morning where that's all going to get covered. Yes. The question concerns open source software for stitching and how are its capabilities compared to the commercial products. I would say check out the Web ODM session tomorrow, which is an open source platform. I would say though, at least for like the flying and the field work, you don't, for the most part, all of these companies, they make their flight management apps available for free. There are open source mission planning apps that are also available, but so you don't need to use, you could use one of their apps. Like we generally use Pix4D Capture. We do have a Pix4D Capture license, but I can take my images that I captured using that flight program and then stitch them with Web ODM, right? So you can mix and match a little bit, but let's pin that and come back to it after you've seen the capabilities of Web ODM is the main open source stitching program, and that's what it does. It's photogrammetry. It doesn't do flight planning. All right, let's move on. I'm going to pass it over to Shane, who'll talk to you about things to think about planning your data storage.
Okay, so let's talk about data storage. This is a very exciting topic that I get super jazzed about. Not really. Okay, so there's 3 levels of data storage that I tend to think about. I think of local storage. So when you're working on your PC itself or your Mac and you're actually download the data, you're going to store it on a local hard drive or a network attached drive, something that's directly tied to your computer. And there are several things to think about on this. The first one is that when you have the data either on your computer or on a attached hard drive, you can have easy backups. You can work with those data directly in your software. So you're not having to worry about pulling them off the cloud, pulling them off a server. You can actively work with the data in your applications. This is really important because if you go to the cloud and try to work with those data from your computer from a cloud resource, it's going to be quite a bit slower. So you got to keep that in mind. It's really easy to manage the data and it's relatively cheap. All you're buying is a hard drive. You can have a network attached drive, a couple $100. You can have several terabytes, and you have a one-time cost. So it's really, really easy to work with. One of the difficulties, though, is sharing that data with others. You have to sneaker net your data. You aren't just going to be able to take a little USB drive. You might, but you're dealing with potentially hundreds of gigabytes of data when you get down with an analysis. So it's harder to share data. I will say, though, that it's very secure. It's on your machine. It's nowhere else, right? So there are pros and cons to local storage. So after local storage, you move into server file systems and server storage. So if we look at the same things, I didn't mention on the previous one, it could be Mac, it could be Windows, it could be Linux. I know that there is a Mac version of server. I've never used it. So I always think about Linux and Windows when it comes to servers. And the thing about servers is they're more expensive. There's a bigger upfront cost to get active, either buy a server or use a server. And the hard drives that you put in servers are sometimes more expensive than standard hard drives. It's still easy to manage the data. It's relatively secure because it's usually within your organization. So you still have that envelope of security and privacy. One thing important is it is really easy to share your data with your colleagues, right? In your organization, it's easy to share your data with your colleagues. It's often more difficult outside. So you still may have to push it up to an FTP site, which is expensive, push it up to the cloud, then they're going to have to pull it down. There's more difficulty with sharing data. That brings us then to the next piece, which is cloud storage. We're looking at Google Drive, Dropbox, Box. Is that OneDrive? What is that logo? Okay, thank you. I didn't know what this logo was, and I should know. So this is cloud storage. You're going to push your data up to it. It's not active data. So you can't really readily analyze these data sets. You can't really process cloud data easily, like in Pix4D, in, let's say, ArcGIS, using the drone processing environments. I had never tried to use Google Drive Stream on your computer to work with data. I would imagine that's painfully slow if you ever tried that, if it even worked. One thing nice about it though is, you can easily push up small data sets to medium-sized data sets to the cloud. You can easily share those folders with your colleagues and they can get access to the data, pull it on their machine and use it. It's not bad. The cost isn't too much. It's relatively cheap as long as you're not trying to have it be always live data that they can pull from. If it's in cold storage, it's cheaper. And so, we use it to store some of our data. It's hard to find sometimes. Like I have problems just in Google Drive finding my stuff. When you start dealing with thousands of images, thousands of files, it gets more difficult. But like I said, it's easy to share. And security and privacy in cloud services, I'm not totally sold on security and privacy. Because you share it with others and you may have to give them edited capabilities and then they can share it with others. You can get this snowballing effect with cloud systems that you may not want depending on the security and the sensitivity of the data that you're collecting. So keep that in mind when you use cloud-based systems. So now let's delve a little bit deeper. We mentioned in that previous slide that it's sometimes hard to find your stuff. One thing that we have found when we deal with our data, because we're dealing with hundreds of flights, hundreds of sites, different projects. We have, I can't remember how many of actual projects right now. I think I should know, I'm in charge of managing all this, 75 to 100 different projects, well over several hundred flights. It becomes unmanageable at some point. So you really have to have a really decent directory structure so you can really keep track of everything you're doing. If you only have one flight or two flights or a handful, it's easy. But once you start having team members and teams going out and flying multiple things, it becomes more and more difficult. So you definitely want to try to figure out a directory structure that'll work for you. In our case, in fact, let me look here to see if this is our case. I think this is partly our case. So we start with the project, the sub-project, then we have a folder that actually holds the unprocessed data. And then after we process the data, we then keep track of where all of our our processing reports are kept, where our GIS data is kept, and anything else that's important to that project. And it's an easy way for us to work with our clients as well as to manage stuff internally. So you should try to put something like this in place. I'm not going to harp on this too much. There's a lot of thinking that goes into setting this up. File naming standard, this is huge. Okay, how many people in here are GIS people? Okay, how many people are just document people, stuff like that? How many times have you done shape1.shape? Shape2.shape? Okay, exactly. GIS people are notorious for doing this, okay? Even if you're doing Word documents, Word test 1, or, grant report 1, grant report 2, grant report STF, you've all done it, right? So we got to try to get around that when we're dealing with drone data. So once again, like I said, it's important to think about data structure when it comes to directories. It's even more important to really think about naming file conventions for your files, because it will bite you in the future when you come up to a file and it's like, oh my God, what is shape 1? You have no idea. What's project 1, field 5? I have no idea. Especially if you're dealing with a colleague like Andy, he's going to pick that up next week and be like, Shane, I don't know what this is. 2 years from now, no clue. You might as well jettison the data because it's going to be useless. So really keep in mind file naming structures. And we point out different ways to keep track of files, how to name files. I think the important thing is don't use special characters. Don't have really long file names, because if that gets included with a really long path name, you might go outside of your operating system's file naming convention structure. So you may get more than 255 characters. And if that happens, you will sometimes get corrupted files that you can't open and read. So you got to be really careful about all these things. Okay, I went super quick there. Questions on data management, data storage, data structure, data directories, all that. Did I lose you? No, good. Okay, you. Ooh, I don't know of anything specific for that. I know that within our group, we really we had a couple long meetings trying to figure out what we wanted. And then we've actually built tools to actually help with the file naming. And then I've actually built Python tools that will prompt you for specific information, and it'll then build out that structure that we've all agreed on. But yeah, we just had to have a lot of back and forth. I've seen nothing specific. And I know Pix4D, one of the softwares, creates a directory structure, but I'll be honest, it's a very painful directory structure. There's so many levels in it that it's not really practical in my view. So you're going to have to come up with your own. Oh, go ahead, Andy.
Yeah, regarding standards and tools for dealing with data structures, my general advice would be, I don't know of anything like that's industry-wide or best practices for like how you organize your data. My suggestion would, pick something that works for you and how you anticipate your data growing. Shane mentioned a programming tool, a Python script that we use internally to create that standardized directory structure. I have an R package that does the same thing. That's another level of unnecessary sophistication for most people. But I did a poster on it yesterday, and I'd be happy to chat with you about it.
Yes, sir. Yeah. That really depends on your file structure and the file system you're in. If you're on, let's say, on a server, so whether it be Linux or Windows, you can lock down servers to individual users, and you can do it that way. Yeah, so you can limit that way, but depending on your teams, you may not want to do that. In terms of someone who administers the structure itself, in my team, that's in general me. But then Sean Hogan, who you've all met, is the main remote sensor for our group, and we all work with Sean on drones. And as the administrator, Sean and I have conversations quite often where it's like, oh, no, that didn't quite follow this structure. We need to modify it. So it's always a give and take when you work in a team. Yes, ma'am. So the question is, do raw images need to be in the same folder as process when you go to process and the processed images? No, they do not have to be. You can have them be entirely different places. You could have the raw images on, let's say, a hard drive, and you could do all the processing on your computer and store it in another location. But for what we have found is for easy data management, after we do that analysis, we eventually put them into the structure so they're very close to each other. Yeah. Oh. Ooh, say that again. Okay.
Yeah, so the question is asking generally, what about raw images, right? So raw images are a file format that's lossless, right? And good RGB cameras mostly have an option to save your image as opposed to JPEG, right? So JPEG is a little bit lossy. So Yesenia points out that a disadvantage of raw images are that they are ginormous, right? A 40 megapixel raw image will be hundreds of megabytes, or they're big. They're really big. That's one problem. You can go in, I know you can do in DJI Go, you can tell it to save your images not as JPEGs, but as RAW. And videographers and photographers, they do that because then they can tweak everything in Photoshop. That generally, in our experience, doesn't work well with photogrammetry. That file size is a huge burden. You're probably, depending on what software you're using, you may have to convert them to JPEG anyway, just to get them ingested into the photogrammetry platform. So we never use raw images. JPEGs are, they're saved at a high quality level, so they seem to be okay. This is not an issue with multispectral because multispectral cameras will save it in a lossless TIFF format by default, and they tend to be very smaller resolution. So we generally don't deal with raw images. Does anybody else have a comment or experience regarding raw images? I think this is only going to be for RGB sensors. Brandon, you want to come over, Brandon?
I'll use raw images on occasion for some of my work. What I usually do if I'm using raw images, I actually do a whole level of pre-processing those raw images. I make sure that my light and white balances are all perfect before I send it to my photogrammetry software. So I take my raw images, I do my calibration with the raw images where I have the most radiometric resolution and I can truly linearize the response. And then I'll move it over to my photogrammetry. Then I can do my processing. And that way, after my photogrammetry, I know that all my reflecting spectrums are all as close to linearly aligned as possible. Of course, it depends on the camera systems that you're using and whether or not you've got a full setup for your radiometric calibrations for your data sets.
Any other questions? Okay. Yes. Ooh, yes. We have used parrot sequoias. We have had that same issue on and off, depending on the camera that we're using. I'm trying to think, how have we gotten around that, Andy? Yeah, let's pin that. We can come back to that. But yeah, we have seen that issue. We have had that issue. Anything else? Yes. Ooh.
Aside from this percent, it's always
Yeah.
a good approach, but you have a share of or average speed is roughly 100 gigabytes per data. For a regular view, is 1,000.
We have not had that experience. In the times where we had to move large sets of data where internet hasn't been reliable, even in like California, we basically end up copying it to either an external hard drive or a large SD card and either walking it to them if we can or shipping it in the mail. We haven't had good ways otherwise. Yeah. Okay, so this is also my next section. We're going to talk about some common gotchas. Okay, so these are when you're out in the field. Andy's mentioned several of these. I'm just going to give them all to you. We have mentioned swapping cards between drones can result in corrupted data. What we mean by this is, let's say you're flying a Phantom 4 and you're also flying a M100 with a different camera on it. The last thing you really want to do is take the card out of one of those, put it in the other, and continue capturing data on the same card without formatting and actually pulling the data off and formatting it. And what that can do is cause corruption. So you want to minimize that as much as possible. So make sure you pull the data off the card, format it, and then you can use it in another drone and just make sure it's of the proper format. Also, the next gotcha is not having the card properly formatted. You've heard several times yesterday and even today that there are different file systems, FAT32, exFAT, there are definitely NTFS. There are different file systems that you can use. And you want to make sure you're using the file system type that your drone, that your camera is used to using and has been developed to use. And you'll have to look in the documentation to make sure you're using the proper format. And you should always make sure that you pull your data off between flights. And this we learned the hard way. We have had drones take off and never come back. And if you haven't pulled the data off that drone before you send it back off and that happens, you've lost your entire data set for that period. And you don't want to do that. Also, the card sometimes gets formatted. You pull it out. You assume your teammate has actually put it in and removed the data. You say formatted, I need to use it. You send it back up and all of a sudden you realize, oh no, that's the wrong card. I just wiped all my data from today. So you got to be really careful when you do that. Also having enough storage in the field. So I'm going to go quick because we're going close on time, so I apologize. So having enough storage in the field, not on the cards, but on your computer, on your hard drive that you're going to be moving the data to. Because like I said, you're going to be generating a lot of data. The last thing you want to do is run out of areas to store that data, because that will end your missions. It'll end your project out in the field that day. Andy mentioned dropouts. This is very important. You could be out there flying a camera, and when you're using these apps, you can actually see the camera take the picture. It'll leave like little dots along the path or different symbols. And if you're not paying attention, all of a sudden you'll notice that you're not really dropping dots on the map anymore. Or you may notice that your photo count's not increasing. And then you really have to start thinking, is my camera working right? Is there an issue? So that's why Andy mentioned bringing the card back, pulling the card out and checking the imagery. So always check your imagery so you can see if you've lost anything. And this, I hate to say, has happened to us in the past. It was the first drone camp, wasn't it? The first drone camp, one of our colleagues was driving from Davis down south through the Central Valley. He stopped for lunch or dinner. Someone broke the window out of his car, stole the laptop. And we didn't have backup copies of the data. Luckily, we had some of it, so we were able to resurrect it, but we had lost some project data because of the way the data was backed up. So it doesn't sound like you'd have to worry about that, but we have in the past, so be really careful. Okay. So common gotchas when you're working with data for data processing. One of the issues is, like I said, you gather so much information. So the one thing you don't want to do is take a flight from, let's say, the morning, and then a flight from late in the afternoon, combine it all together, and then try to process it. You're going to get most likely really bad process results because the lighting is going to be completely different. You're going to have completely different shadows and all that. And if you don't put it in a good structure, it's going to be hard to discern that. And the software, if you try to run it through, isn't going to work. So try to really get into the habit of having a good data structure. And in what I have found is if you have multiple flights for a project, I tend to process the individual flights by themselves and then merge them together at the end, because sometimes you can have an issue if you just try to merge multiple flights, even if they're very close together. So that's something to take in mind. And I already mentioned too many characters in the path name. That's just really a matter of your naming, your file naming structure and your directory path structures. So keep that in mind. You do not want to get over 255 characters. And that is a limitation from DOS, from back when DOS was first developed. So 256 characters is an issue. So just keep that in mind. And I think that's it for this slide right now. I know that was quick. Any questions about gotchas? I know we have a bunch for people who've done drone stuff before. Okay, what do we got? Ooh.
So I'll read some of the questions on chat. Do the manuals of drones have the correct format for the use of the SD cards? Yes. In general, all modern cameras, the RGB ones, they can take any kind of formatting. This tends to be an issue with the multispectral cameras, the Altums, the Sequoias. So check those, check the documentation. It'll say you have to put in a memory card that's, FAT32. Those tend to be older ones. There's a couple questions about image calibration. Is it necessary? Can't you just use the set of images from the drone to do your orthomosaic stitching? Do you have to do image calibration? Those are good questions. We're going to talk more about that tomorrow. In general, yes, you can pull images right off the card and feed them right into your stitching software, and that will work. Calibration definitely comes into play when you're working with multispectral data, right? So that's where like you have the different band for the red, the near infrared, and so forth. Those need to be calibrated because your goal there, it's a different goal, right? Those are research projects. You're trying to get some kind of product, an index or something that's kind of standardized so that you can compare this week to next week. You can compare this area to another area. You can compare your values to the literature, right? So calibration is necessary on multispectral data generally. Brandon made a reference to doing some calibration on raw images for photogrammetry. That's kind of a niche application. He's probably trying to get the absolute best quality, the best stitchable imagery, and the best looking output from that orthomosaic. But I think we'll go through some more of that when we talk about photogrammetry tomorrow, how the software stitches the images together. Anything else to add on those?
Yes, sir. Yeah, I would say that you put it back in and format it, because then you know it's clean and you know you have the format that you're anticipating. So I would just take that extra step, do a quick format. It won't take long, and then you can get it back up in the air. Anything else? Okay. I think you might be up.
Okay, so we'll finish up by talking about, in general terms, some of the options for sharing your results. So let's think, what do we mean when we say sharing your results? That can be anything from simply making a figure in your publication. A lot of times that's your goal. That's all you need to do. All the way at the other end of the spectrum where you want to share everything you've done, either with your colleagues or for a journal. You want the whole thing to be reproducible. So you have to share your raw data, maybe your processing pipeline, right? So to be reproducible, these are the steps I took after I got the images, how I collected the images. You may just want to share the existence, the metadata, right? So I collected these data. Here's where it was, this is the type of data it was. If you want a copy of it, let me know and we'll talk, right? So all of these, there's different, when we say sharing data, that's not just one thing. We talk about different stuff. These are some of the tools that do everything on that spectrum we just talked about. I won't go into great depth. I will give a shout out though to Open Aerial Map. That's one of the few kind of citizen science. It's from the community that created OpenStreetMap, and it's a platform. You can upload your processed imagery. I don't think they support raw imagery, but you know, you can have a URL where people can find how to get your raw imagery. And it's decent. You can get a preview and you can actually download the TIFFs. Most of these other ones, I think all of them are proprietary. Dryad is a research tool. If you belong in a university and you want to share your raw data, you can upload data there, get a DOI for it. The other ones are all commercial products. But you know, these are some of the options. Creating catalogs of your data, not a bad thing to think about. This would be like to help people know that your data exists out there, right? So they could maybe find it. Creating a data catalog. There are not a lot of tools that do this. I'll start out with that. You know, metadata will include, you know, from the images. So the images have saved the GPS location, what kind of camera it was, the focal, you know, the field of view and so forth. But then there's also the flight metadata, right? What day was it on? What were the goals? What was the altitude? Some of that's going to be flight metadata. I have an R package that its main role is creating data catalogs. I could show you what one looks like if this works. Let's try this. Oh, okay, what is that? Is that gonna work? All right, that did not work. I will show, but they're basically very simple HTML pages that are standalone, and you can use them to, you know, you click on you can see the camera locations. You can click on them, get a thumbnail image. If you've got a bunch of pictures together, you can put them all together in a table of contents. So it's just a way to share that you've got this data set. It doesn't do stitching or anything like that. All right. Okay, and then ultimately, you may or may not have heard of Feirer. This is kind of a gold standard for reproducible research. It's getting a great deal of interest making, in the research world, data sets that are findable, accessible, interoperable, and reusable, right? So if you're in an academic situation, this is the gold standard. It's much more further along, both as a concept and as tools and training in the EU. but even some of the funding agencies in the US are asking you for a data management plan that has these elements to it. It's a real shame that there's so much drone data out there of mixed quality, but a lot of it's really excellent quality. It's irreplaceable, and it's just all dark. You know, nobody's going to find it. And it's kind of a shame, right? Because this is data that could be very useful, you know, 5 years from now, 20 years from now, for all kinds of science questions. And so it's something I wish, or I'd like to see the industry go like with a share button, right, on your photogrammetry software, that at least you can share the existence of your data. But we're lucky that ArcGIS has made progress on developing an ecosystem of tools that does some of this. I'll turn it over to Shane to finish this up.
Okay. So we're going to talk about the ArcGIS ecosystem. One of my roles with the group I'm in is I am the GIS manager, and I manage and work with ArcGIS. So I'm here just to quickly hit on a few things that ArcGIS can do these days. Okay. So we're going to talk about ArcGIS Pro, which is their flagship product for GIS, and we're going to talk about ArcGIS Online briefly. So from ArcGIS Pro, what you can now do, and you've been able to do this for a while, is you can go to the sharing tab, and you can do all these things from the sharing tab. So I'm just going to quickly highlight a few. So you can take a project, your map project from ArcGIS Pro. You can share that to your computer, make a file, send it to all your colleagues. It takes all your data, all your maps, all your layouts, and puts it into basically a fancy zip file. And you can send that to your clients, and they can open it and have the exact same thing on their computer. It's really nice. It's pretty straightforward to use. You can also go in though, and not only share it with your clients, you can push that up to ArcGIS Online, share that with others in your organization, everyone, or even just specific groups in your organization. So they make it really easy to share your results. You can also create map packages, which allow you to just take an individual map and share that in the same way. You can make a mobile package, which allows you to open up that map on a mobile device and actually use it out in the field. I haven't done this as much, but you can basically package up your project in a way that can be used. Also from within ArcGIS, you can actually share things to ArcGIS Online directly from your map in ArcGIS Pro. You can share it as a web map, so it's going to have all the formatting, the symbology, the base map, as well as all the data. You can push that up, share it as a web map, share it with your colleagues, or just in general to the public, and they can see your data. Really straightforward, really easy to use. But then you can also go in and you can share your maps, you can share your layouts if you have custom layouts, and you can share those with your colleagues so they can all have the same look and feel of their maps and their cartographic products that you want to produce. As always with GIS, you can also create PDFs, JPEGs, TIFFs, and stuff of your map, and you can share that with your colleagues, and you can print your stuff. Really straightforward, all within one toolbar inside of ArcGIS Pro. And if you take the ArcGIS sessions, whether it be the UAV processing tomorrow or the intro to ArcGIS and data mapping of your UAV data, we'll go through a little bit of this tomorrow. So this is all using the desktop software. Very similar to what we were talking about with local storage, but this is local desktop, local GIS on your computer. So not only can you push data and have it available up from your computer to ArcGIS Online, you can, if you have access to an enterprise server, so like a Windows server that's running ArcGIS server, you can actually create image services. And you can expose your drone data as image services on ArcGIS server, which will allow your colleagues and even the general public to have access to pixel level data, multi-band data that they can use in their own analysis inside of ArcGIS Pro or in ArcGIS Online. And you can do this as long as you have a server running ArcGIS server. So they make it relatively easy to share stuff. I should note that all of these applications, there are levels of security and privacy that you can set on your data. You can have it available to everyone, to just your organization, to members or groups of people in your organization, or just to yourself. So they've tried to think about security and privacy. Something relatively new, I just want to highlight, this is all within the last 6 months. There's now a new addition to ArcGIS Online called Image for ArcGIS. How many people are familiar with ArcGIS Online? A handful of you. Okay, so ArcGIS Online does really good with vectors. There's a lot of vector tools you can do with feature hosted layers and stuff like that. Within the last 6 months, Esri has released image for ArcGIS Online. It's an added extension, of course, that we have to pay for, but it actually exposes raster analysis to ArcGIS Online. You can take image data, processed image data, and directly push it up as if it's a image server. They'll host your pixel level data, and you can then run a myriad of additional raster analyses using ArcGIS Online and the power of AWS under the hood, because that is actually where ArcGIS Online is hosted. And of course, there's a cost of credits and everything else. But because it's in the ArcGIS Online system, you have the security and privacy levels, just like in ArcGIS Online. So it's fairly new. We've been working with it over the last 6 months. There are some nice features and there are still some bugs. So I just want to let y'all know about this. And the last piece of the ArcGIS puzzle you've heard about back off and on yesterday and today is ArcGIS Site Scan. This used to be 3DR Tower a long time ago. ArcGIS bought it and they've added new functionality and have continued to develop it. There is a standalone mobile app for gathering data. You can do mission planning, you can do terrain following with that app. With that app, you push the data up to the cloud. It gets processed in the app. But one other nice thing about this application, it also helps you manage your enterprise fleet of drones. It keeps track of serial numbers, how many hours they've flown, keeps track of all of your batteries and how often they've been used, how many times they've been charged. All this thing is actually just taken care of by the software itself. This has potential, and we've been enjoying this as we've been demoing it and testing it. I mentioned to the gentleman over there earlier that they often charge by the number of images processed. And this is one of those examples. So they make it available to you, but you're like, you get 25,000 gigapixels at one level. And then as you go higher up, you get more. So it's not the number of users, it's just the number of images that you process. So there's a lot of options for ArcGIS. If you have questions throughout the day or tomorrow, flag me down. I'd be more than happy to talk to you about it. So with that, any questions on ArcGIS in a quick hurry? Yes. Yes and no. Yes and no. So there is a free version. There is a free version of ArcGIS Online. The question is, or more the comment is, ArcGIS Online is free. Yes and no is my answer, because there's a free version and then there's a paid version. The free version is you can't have groups, you can't have people join your group. There's a bunch of limitations on it. But then there's the organization that you have to pay for. And if you do that, you can have multiple named users and licenses and all these different things you can do. But for anyone who's wants to do and try this software out, you can actually get a personal license. It's $100. It lasts a year. You get ArcGIS Online, you get ArcGIS Pro, you get all this software, and you can use it. You just can't use it for monetary reasons. So you can't do contract work with it, but you can get the software for $100. Yes. Yeah. Yeah. Andy, do you know? It's whether or not that if you're going to publish your results in a journal, does the journal want access to the raw data, or is the result and the images sufficient? The answer is it depends on the journal and what they require. And the reviewers. Thank you. Okay. I should mention, you had mentioned ArcGIS Online. You had said something that triggered something in my head. I lost it. If anyone wants to talk about ArcGIS, let me know, and I'm here for that. Any other questions? Oh, yes. So the question is there a place in the metadata where you can tell that the location was determined by RTK? Brandon, you got this one, or Andy?
Actually, in most of the DJI systems, the RTK is not necessarily always connected to the GPS or the metadata. And honestly, it's actually not going to tell you in the metadata. That's a tough one. It's going to be dependent on the aircraft model. So you'd want to check with the aircraft model and see how they manage the metadata tagging of GPS locations, if it's coming from the RTK or the regular GPS on board.
Yeah, speaking with eMotion and the SenseFly platforms, which are RTK, basically the same thing. So you just, if I give you one JPEG image or a TIFF image, you're not going to be able to say, is this RTK or not? There's a coordinate in there. You may or may not know if it's an RTK coordinate. So when the SenseFly flies, the images do have stamps. They do have locations. They may or may not be RTK corrected. They may not be high quality. And that particular platform, there's a process you go through after the aircraft lands, and it'll go through all the images. And if they didn't get a high quality recording, there's a process where you can do the post-processing and upgrade the images. But that's going to be specific to that platform. It puts them in another folder. So the short answer is it's probably going to be platform specific, but there's no easy way to determine if a specific data set is RTK or not, I believe. Any other questions? Yes.
Ooh, I love that question. The question is there a specific color model or color palette that you would use for publication or posters? There's no specific color palette that I would use, but what I would do is avoid, obviously, green-red palettes, but for color blindness. But also, there are actual websites that you can go to where you can actually test your image to see how it would look to someone with different color blindness types, and you can really get a feeling for what would work and what would not. We also go to, I think it's Jan Brewer, is that right, Jan? I think it's Jan. Color Brewer, it's a website that has, you can actually choose and say, show me colorblind friendly color palettes, and they'll give you color palettes that work. So there are different ways to do that.
There are many, many resources online. If you just Google colorblind friendly maps and infographics more generally, there's lots of suggestions. There's sites where you can preview how your map looks to someone who is colorblind. There are these various palettes which are more colorblind friendly. So it's good to have that in mind, though, to be thinking about that.
And ArcGIS Pro, I should mention that they do have colorblind sensitive palettes built into their symbology. You want to turn on to show the names, and then you can actually see the Color Brewer palettes. And I think they may even indicate if they're colorblind specific. So just as a note. So okay, so at that, let's take a short 5-minute break. So please stretch your legs, do whatever you have to do. We'll meet back here at 11:35.